movement of the large intestine. I just want to point out a couple of things. So the ascending colon is nestled right here along the right hand side of the abdominal cavity, and the groove between that and the abdominal wall is the right paracolic gutter. The descending colon on the other side is kind of mirroring the ascending colon's position. It has the left paracolic gutter between it and the abdominal wall. And just a reminder that the right colic flexure is tucked in right in underneath the liver, whereas the left colic flexure is tucked in right next to the spleen, and that's where they get their names, hepatic and splenic flexures. Okay. So then, talk about the arterial supply, and nice thing about the arterial supply in the abdomen is it is mirrored by the venous, lymphatic vessels and the nervous system. So they all travel at approximately the same pathways. So if you know the arterial supply, you'll know the basic structure of the other systems as well. And remember that the forepart of the gut, or the mid part of the gut, is supplied by the superior mesenteric artery, and actually the midgut extends from the excuse me, all the way to either the junction. There's some discrepancy in the description. Junction between the transverse colon and the descending colon, right at that splenic flexure, or about 2/3 of the way across the transverse colon. So that's the division between the midgut and the hindgut. So from here on is hindgut. And that is where the area that is supplied by the inferior mesenteric artery. Okay? And that then goes all the way down, supplies the rest of the sigmoid colon and rectum and anal canal. Okay, so you don't need to know a lot of the details of the system. Basically, make sure that you know what areas are supplied by the superior mesenteric artery versus the inferior mesenteric artery.
Can you say where the midgut is again? Is it between those two?
No, midgut is
the first.
All this stuff over here.
Okay. Thanks.
The two lines are representative of discrepancies of where people say the division between the midgut and hindgut is. So, but it's somewhere in this area-ish that make that the division.
Here's a little fruit place. I promise I'm not crazy. Ish.
I look like that when I'm sitting out on the back patio. Okay, so then I just want to touch on a couple of abnormalities in the gastrointestinal system that are congenital or can be congenital. So this one here, this is an image showing a barium contrast X-ray image with torsion of the gut, or they call it volvulus. I'll make sure I spell it right. I can't spell it right. This is me trying to type a quiz. Okay. And this one, the valve is twisted and blocks off the movement of the contents through, and so you can see here lots of barium in the stomach, in the pyloric antrum canal area, and duodenum, but then here we've got a torsion here, a twist in the valve there, and very little barium has gotten through for the rest. This structure actually has multiple torsions, multiple twists all the way along. If it's sufficiently twisted, cut off for that, to actually cut off blood supply, and the area can become ischemic or infarcted, so loss of blood supply causing tissue death. The other one I want to talk about is diverticula. So diverticula are little outpouchings here of the colon wall, and often these have a congenital basis if the abdominal wall is slightly weakened. You also can develop them people who don't eat a lot of fiber, so that require requires a lot of the pressure from the intestinal muscles to push the contents of the intestines through. And so that can also weaken the wall, and you get these little outpouchings of the wall. And then you can get anything getting into those little diverticula or blocking the orifice of the diverticula can set up a system basically like blocking off the orifice of the appendix, get inflammation, swelling, all that, and that gives the condition diverticulitis. So inflammation of the diverticula. There are other congenital diverticula that are what's the word I'm looking for? Embryonic structures that haven't quite disappeared, so patented embryonic structures, as well besides these ones along the colon. Okay, any questions?
So that diverticula, they're not normal?
No. So these are extra outpouchings of the colon wall because it's gotten weaker and the pressure of moving the feces through has actually pushed out the wall in an extra pouch. Okay. All right. And then just a couple of things to point out for anatomical features of the rectum and the anal canal. So the rectum, identified by the lack of haustra, or visible haustra. So smooth as opposed to the saculations of the rest of the colon, and then narrows down to the smaller canal of the anal canal. Okay, so just a couple of items for that. Okay, arteries supplying the rectum and the anal canal. So they would be branches off of what main artery? Inferior mesenteric coming, and that supplies the superior rectal artery. Is a branch off the inferior mesenteric. Ouch. We also have branches off of the internal iliac artery coming down to supply the lower aspects of the rectum and the anal canal. So superior rectal canal is part of the inferior mesenteric artery branching. So another small area, at least we have a little bit less confusion when it comes to the vessels in that spot. Okay, so any questions about the colon, large intestine, small intestine? Okay. So then let's charge into the liver. Talk about the liver a little bit. So predominantly it's located in the epigastric region here, with the right lobe also in the right hypochondrium. And then nestled up underneath the inferior aspect of the rib cage. Nice protected spot for it, and tucked up in right underneath the diaphragm. So you can see here, tucked up underneath the diaphragm. And then a couple recesses I'll point out. The hepatorenal recess here, kind of going down along the inferior aspect of the liver. And in the video we watched of the appendectomy, saw him kind of really digging down in underneath when he was sucking out all of the fluids and washing the abdominal cavity out. He was really getting down into this recess to make sure that there was no blood or anything left in there to urinate. The visceral peritoneum in that area. And we also have the subphrenic recess here, kind of going between the liver and the diaphragm. Right, so then we got obviously the right and left lobes of the liver, and you guys have been learning the ligaments that come out of it. So we've got here the falciform ligament, and this round ligament here Just wanna note that the right lobe and the left lobe, and the other lobes that we'll talk about are superficial lobes. It's not a functional segregation, it's just anatomical. Okay? So on the, not the anterior, that's the other one, posterior, here we go, aspects of the kidney, or, liver. So we also can see the inferior vena cava tucked in there behind. This can actually be completely surrounded by the liver tissue in some individuals. We also have all these impressions where the liver's kind of roaming around other organs. You don't need to know the names of them, but just know that the liver's kind of just roaming around all those other organs. And then we see the gallbladder sitting here in the inferior aspect of the liver. And remember the fundus of the stomach, so here we've got another fundus, the gallbladder fundus in a dome, then the body, and then the neck as it narrows into the cystic duct. Okay. And then let's flip the we're the one called kidney. Liver, upside down, and look at a couple more structures. So I want to point out the porta hepatis. And this is kind of like the hilum of the liver, but it's not called that. So it's called the porta hepatis, and this is where all of the vessels interact with the liver. So the bile ducts exit and the veins and arteries enter. Remember, we've got the portal vein coming in and the hepatic artery proper providing the nutritive supply. And then the hepatic ducts draining bile. Ouch. There's a small lobe next to where the inferior vena cava comes by the liver. That's the caudate lobe. Okay. And then by the gallbladder, we have the quadrate lobe here, so this lobe right here. Okay. Let's see. And then just a CT scan, start to get you guys started looking at CT scans of the liver, so it's big, nice big gray object. You can see the portal vein here coming in. Here's the inferior vena cava, kind of tucked in behind liver. And the gallbladder, kind of a dark structure right there. Okay. So then, this is not a picture in your book, this is from your path list. I like the way it showed the branching of the vessels within, and ducts within the liver. So we have, like I pointed out, we've got the hepatic portal vein and the hepatic artery proper, or they are saying proper hepatic artery, coming in. They all branch together and interconnect with each other as they spread throughout the capillary beds of the liver. And then they're drained through the hepatic veins here. So we've got several different hepatic veins coming into the inferior vena cava and draining into the cavovenous system. I also want to point out the bile ducts, how they also mirror the branching of the veins and arteries. Excuse me. And we'll talk about the importance of that in a moment. And I just want to take a little quick zoom in here, point out the cystic artery. This is a branch off of the right hepatic artery, which is a branch off the hepatic artery proper, that provides the nutritive blood supply for the gallbladder. So then, all this segmentation of the arteries, all the branching of the arteries and veins and bile ducts sets up a system kind of like what our bronchopulmonary segments in the lungs. So we have the same kind of segmentation in the liver. So each of these segments is supplied by one of the major branches of the hepatic artery, receives blood from the major branches of the hepatic portal vein, and also is drained by one of the major branches of the bile ducts. I wanted to point out also that the whole tree of the whole network of bile ducts is called the biliary tree. I meant to point it out on this slide. So all the bile ducts, everything. Not really, but anyways, it's biliary tree. Okay. Let's bounce back up here. So these segments, like I said, they're kind of like in the lung, the kind of functional segments of the liver. So when they're doing like a tumor resection of the liver, they'll take the entire segment out. If they want to do a transplant, partial liver transplant, they'll take an entire segment from the donor and put it in the same location in the recipient. And then they just have to match up the major vessels to get the transplant to line up and to take. Also, liver is remarkable in that it can regenerate itself, even from just a small piece left. So often if they do a resection of part of the liver, if the metabolic demand is high enough, that part of the liver will actually regrow. So we get some regeneration. Okay, so and like for the lungs, you don't need to know all of these segments, you just need to know the concept of different major branches of the arteries, veins, and biliary tree correspond to different functional segments of the liver. Okay. So then let's turn our focus to the gallbladder and try to get through that in the last few minutes of class. So we've got the gallbladder here as a storage. What am I looking for? Structure or whatever for bile, and so the cells in the liver are constantly producing bile, is draining down through these hepatic ducts into the smaller hepatic ducts into the main hepatic duct and into the bile duct. And there's a papilla that maintains, that's got a sphincter that closes off the bile duct so that we don't have it constantly emptying of the bile into the small intestines at the bottom of them. So eventually the bile gets backed up and backfills the gallbladder. Then when the body senses it needs some extra bile, it helps. Oh, that hurts. Break down some ingested fat. It opens that papilla, releases the bile, and also the gallbladder has some smooth muscle. So there's some smooth muscle in the wall to help contract the gallbladder and hasten the release of the bile. Here's just a contrast image here of one branch of the biliary tree. See it branching out from the common hepatic duct into this area. Here's the cystic duct leading to the gallbladder.
So does the common bile duct go from the liver to the gallbladder?
And the common bile duct is from where the gallbladder cystic duct attaches to the hepatic duct. So this is the hepatic duct here. And then we got the cystic duct here. And then here we've got the common bile duct or the bile duct. I've got another figure in here somewhere that shows it. I think down when I talk about pancreas. Because they both come into a common duct there, bile duct. Okay. Any other questions? Yeah.
two arteries labeled as left gastric artery, but it's not one and the same thing.
Where are we at here?
Like,
Oh, left gastric artery.
is it because they like cover each other?
This is the gastric artery there. It does look like it's.
And then
pointing to
further
two.
down on the bottom, like.
Oh, there, I see what
it
you're
says
saying.
left gastric artery, it's pointing to one. like
That should
another
be
branch.
right gastric artery. Yeah, so that is not right. So that should be right gastric artery. Good catch. Then remember, the right gastric artery is a branch off the common hepatic artery. Good catch. Okay, any other questions? Yeah. Andy?
So is it hepatic artery proper or common hepatic artery, those different?
Yeah, so the common hepatic artery is that branch off of the celiac trunk, right?
Okay.
And then at the point where the gastroduodenal artery branches off, then it becomes the hepatic artery proper. Okay? Any other questions?
So then these are branches of the hepatic artery proper, the right and left.
The right and left hepatic artery are branches of the hepatic artery proper. Yeah. It's amazing, isn't it?
Could you draw out the separation again? Because isn't that the
Separation of.
of the hepatic artery proper and the common hepatic artery?
Yeah, sure.
Are we able to see it on this one? I didn't-
Let's actually go back to, or do I have it in front? Let me just look real quick. Yeah, here it is. Okay, so we have the common hepatic artery here, right here.
Okay.
So do the common
Gotcha.
hepatic. Okay, then we have the hepatic artery proper here. And then that's right where the gastroduodenal artery, so.
So that's our
Your
separation.
gastroduodenal arteries coming off there. And then we have a split between the right and left hepatic arteries there. Does that help?
Yes.
So common hepatic is one of the.
I don't know exactly how long, but it's short. Yeah, it's very short. Only marginally long in the celiac trunk.
Okay.
Yeah, good. Any other questions?
Gastroduodenal
We got this
separation.
pathway straight here. Absolutely. So, class is over. Look at it as long as you want.
Bye.